Hi guys, our third example in kinetic molecular theory of gases, we're gonna see how we could find the molar mass and possibly also the actual identity of a certain molecule when comparing it to the speed of a molecule that we know its molar mass and the temperature it's at. So in this case we have find the molar mass and identity of the diatomic molecule. So diatomic means made up of two atoms, either the same atom or different. In this case, the diatomic molecule that we're trying to find out, it's made up of the same element. So knowing that it is made up of atoms of the same element and that it has the same speed at 158 Kelvin as argon has at 280 Kelvin. So the speed that this molecule, the unknown molecule, has at this temperature is equal to the same speed that argon has at this temperature. So how do we go along solving this problem? So if you watched example number 2, we used URMS equals 3RT over molar mass, and we just compared, we just said URMS of, let's say in this case argon, is equal to URMS of our unknown. Now, I'm going to do this one more time, but the next time you might see such a question, I'm going to show you an easier way to sort of come up with the solution without having to go through all the cancellations over here. So in this case we have 3RT over molar mass of, in this case, argon, and then here 3RT over molar mass of X. So we square both sides so we can get rid of the square root. Now, this is the point that I want to get to. The R would cancel off with the R and the 3 would cancel off with the 3. And this happens to every single time we actually use a comparison between two speeds. So if we have a comparison between two speeds, every single time the R does not change from one element to the other. So the R is going to be constant, so you can cancel it off. And the 3 is not changing, so we can cancel it off too. So from now on, when you see such questions, you could right away start with the T of the element that you have, let's say we have argon in this case, over molar mass of argon equals the temperature of our X unknown over the molar mass of our unknown. So that's pretty straightforward. Reorganize the components of this equation. Molar mass X would be equal to temperature of the X, which is 158. We're going to substitute the numbers after, times molar mass of argon over temperature of argon. So if we switch up the values now, we have 158 Kelvin times molar mass of argon is 40 grams per mole over the temperature of argon is 280 Kelvin. So Kelvin cancels off with Kelvin. You do the calculations, you should end up with around 70.88 grams per mole. So it's around 71 grams per mole. Now, they told us that it's a diatomic molecule, so it's made up of two atoms. And they also told us that the atoms present in this diatomic molecule are of the same element. So if they are from the same element and there are only two, then the molar mass should be, in order to find the molar mass of one, we should just divide the molar mass total by 2. So I'm going to just continue this over here. So 71 over 2, that should give us 35.5 grams per mole. So at this stage now, most likely you will be given the periodic table in your test. So you just go through the periodic table and see which one has a molar mass of 35.5 grams per mole. In this case, we know that chlorine has 35.5 grams per mole. So the molecule of interest is Cl2 gas. There you go, guys. So we managed to find the molar mass and find the identity of the element that we're studying, or the molecule that we're studying, all from the equation measuring the root mean square speed.